Right, well, this should be 2 JWRs. They have been sent to us as a gift, but I have said to the person who's given them that we will offer them back at repair cost only, if that works out and if that suits them. So we will see. They may be beyond economic repair. A lot of these get messed with in an attempt to turn them into 10-metre amateur radio sets. Most of those attempts failed, and then 40 years later we end up with the person who did that having passed away, and these things end up on eBay. So let's see which is the best way into this. Swizzle's drumsticks. We wish it was a box of those, don't we? Yes, various bits which got taken out. I don't mind showing notes as long as it doesn't have personal details. Please use both these radios for parts or to keep others running, or do as you wish. Did work until modification was removed, but it didn't work properly. That was the thing. It wasn't on the right kind of frequencies. Right, put that to one side. So there's two sets, as it says. They're not the right screws. There's a speaker missing. Can't see a speaker. This is on the back of doing that Signal 1001. The speaker's missing as well. So we've got a photo. We did have a photo of how this is supposed to be, but it may now be discarded. That was the Harvard. That is the base, the Union 300 base that's still here 2 months later. Not that one. It's not that one. Check with the file It's not that one. So we'll probably have to print off some more info. So these do follow resistor colour code. Brown, red, orange, yellow, green, blue, violet, brown, red, orange, yellow, green, and then violet, blue. That goes to there. So that all looks wired correctly. I mean, it all looks done properly. But let's have a look under there. Isopropyl alcohol to hand. And this has all been done. I mean, that does look okay. Let's put the let's buzz it through with the multimeter. So that goes. This is going to be a long video. That goes. That goes. That goes. That goes. That goes. That goes there. Well, it looks demodified well. So we will connect it up to power. We'll switch on the test gear. And put the signal generator on UK 2079125. We're not going to get any receive, are we, without a speaker plugged in or a mic plugged in. Put the test gear in. Now I may have to make up a mic. So we've got a jolly good signal, there's nothing happening. Sometimes these low high power things have been repurposed, and it's certainly been soldered. We might have to take our Signal 1001 apart, which we did the other day, because that hadn't been messed with insofar as... What's that wire? Is that the speaker? It can't be. No, that's the speaker. No, there's a brown wire there. There's a brown wire. That's going to be key, isn't it? That's your speaker. Right. Pause the video and find the Signal 1001. Right, I found the Signal 1001. I've got a sneaking suspicion it's Cybernet wiring on these. Let's put picture in picture on. Showing in the monitor, let's hope it's actually recording like that. And we'll just use the extension speaker on the wall. Press transmit. Nothing. Right, here's our Signal 1001. So we'll just open that up and we'll compare. I better put my smouldering bat on. I think these are I think they still are M3 screws. We'll find out. So unsolder my speaker so that we can actually see what we're doing. I don't think the soldering iron was warmed up. Getting there. We've got a Murphy DS602, which is basically the same set with the LC7137 synthesizer instead of this Motorola general purpose thing. So, but the layout is such they tend to hum on transmit. Electrically, it's quite similar, other than the synthesizer. Right. So, where's this brown wire on our set? So it's resistor 318 to what? Well, it goes to the mic socket. Oh, that's because nothing goes to the mic socket at the present. Right. Just tidy it up a little bit. It's still not receiving, whether they have the mic, any wires going to the mic socket or not. Right, that's our brown one. Then we've got this orange one, which also goes to the mic socket, and that goes to the pin, making sure the orientation's the same. No, the orientation's back to front, so I've just wired that wrongly. You couldn't make that up, could you? So back to the brown wire. It's the pin to the left of the locator. Take the main connection back off. Pin to the left. I've unsoldered that again. Which is that one. So the orange wire goes to the pin the other side of the locator. And then have we got a third wire? Got a black wire which goes to the board, which is that one. And that goes to both the other pins. So we can put that so we've got a shorting link. And then the black wire. Right, so that's not got our mic socket reconnected. It's not going to alter the fact that the set isn't I don't think the synthesizer is running on it. But we can plug the mic in now, and at least we can make the thing go through the motions of going into transmit, even if it doesn't transmit. And we've got the TX light, which is all handy. Right, so unplug that, we don't need it for now. So looking at the wiring, which is what we're doing, sure this is correct. So they follow the resistor colour code, they do. They follow the resistor colour code, and then when we get to this end, follow the resistor colour code, except those two which are the other way around. So it's absolutely correct. So you can only think that the synthesizer chips had a static belt and it's killed, or is 10.24 not running? So I'll get the oscilloscope and use it as a frequency counter. Locate where the crystal is. You've got the coil. You've got the synthesizer chip. I'm just going to wiggle it with this soldering iron to be absolutely sure. Yep, that's it. Let's put our earth to a chassis point. I think these are negative earth anyway. And we've got 10.24. So we know the synthesizer, the reference crystal is running. Is it simply out of lock? I can't even remember which is transmit and which is receive VCO. I mean, that's one, that's the other. But there's no reason, you know, that's never been disturbed, so there's no reason why it should be out. Let's go put the mic back in. Put my little walkie-talkie on. Nothing's transmitting. Right, we'll get the. I'll have to get the service information, and we'll take it from there. I think we're going to have lunch first. All right, back to this. So I've printed off the instruction book, which has circuit diagram and more, like a parts list. Does it have a layout? No, we won't be that lucky. And then we've got this conversion information, which helps us because it's got a bit of a layout and it's got a bit of some instructions and so on. So if it worked before, it doesn't work now. Have we lost power to the channel selector switch, however that works? Otherwise, it's got to be the synthesizer chip, hasn't it? Or it's out of lock. So the code switch does get power from the 5-volt rail diode 203. So if that's a 5-volt Zener, we should have 5 volts there. All we've got to do is find 203. I wonder, is it that pink wire which is the... .203. Let's put my probe down there so it's shrouded and it doesn't go down very, very easily. We've got 7.5 volts on that one. Diode 206. .302, 301, 203. We've got 7.5 volts on it. But is that correct? Is diode 205 supposed to be 5 volts? We've got a parts list here, haven't we? It's not complete, but we've got a parts list. 305. So it's an SVC251. I'm going to go and look that up. So I'm talking out of my bottom. It's 203, isn't it? It's just a 5 volt Zener. SVC251 is a varicap diode, and it should be 5 volts. And we've got 7. So if that's gone, open circuit, has it popped? There's 203. Has it popped the phase lock loop? So it looks like it's that there. So that's, we're going to take the power off, because if that's totally missing and we power up inadvertently, there'll be quite some toast. Right, wrong way. There is it. Choose that one. Oh, stubborn. But I got it the wrong way round. Here's the problem, I haven't got any 5 volt Zeners. Greater than 50 volts it says, so it looks like it's open circuit. And that's not good news. It's not going to suddenly start working when I replace that, because everything else has had too high a voltage, hasn't it? So our Zener's there, so the code switch will have had too high a voltage, so it's going to have affected, yeah, and the power to the IC will be too high, and I expect everything's had too high. Right. I'm just trying to think if I wouldn't normally recover a Zener from a scrap chassis. Obviously we'd test it if we did, but I don't think we've got any scrap chassis of this type of set. I could have sworn on a stack of Bibles we did at some time. We have to have another look through stores. We might have got Zenas under another number, because we've got a general kit of Zenas, and then we've got them stowed away like the Mullard ones, like BZY88C whatever. So I think we'll have a look through that that box of Mullard type diodes. So the next day, oh, we haven't got any cameras on the second channel, so we won't do any picture-in-picture at the moment. We've got a delivery from RS. So this is like 18 hours later, which hopefully is relevant to this. No, it's not. 0.33 microfarad capacitors for another job. Okay. We'll pause the video again. Right, we've got another delivery from RS, but this is so big I didn't expect it to be that. You can't reuse these RS boxes. Well, it's not that. Well, it says the diodes are in this box. They are. So what we've got, AA batteries, I think. Yeah, sometimes we need to do field tests on walkie-talkies. Yep, RS alkaline batteries. And diodes. So we're using a different number because we know it's a 5-volt Zener. Well, it's 5.1 volt. We're using the Mullard type numbering BZY79C5V1 as a general way to go. So these are 500 milliwatt, which is what's going to have been in anyway. I think I looked at the data sheet. So we'll take one of those off the bandolier. So we've actually got 5.1 volt Zen. I've ordered from China a Zener kit. We do have a cheap Chinese Zener kit, but it's voltages above 10 volts. So I've ordered one which is voltages below 10 volts. So at least with this we know which is the hot end. Don't tell me we've got a flat battery on this. It looks like we have, doesn't it? Okay, anyway, we know it's going to work, so. So all we've got to do is to put it in the right way round. And luckily, the board is labelled. So chances are, the phase lock loop chip will have been zapped. But there's a possibility, there's always a possibility it hasn't, but the fact is surely the radio would have worked. Why won't that go through the hole? The hole looks clear. Obviously there's something there. I'll leave it slightly proud of the hole because they get hot and it'll be easy to meter it, or warm. So it isn't going to burst into life, but we should now have a 5-volt rail on the 5-volt rail. I don't think you need me to tell you how much that costs to get a small order like that delivered. Right, power on, 13.8 volts, radio on, and let's see what we've got across this diode. We've got 5.2 volts, which is what we want. That's better than 7 point something, isn't it? But it's going to have killed the radio. So the next real move is to look at the data sheet for the Motorola MC145106. We'll see what those maximum voltages are, and then we can assess whether that's going to be killed or whether it's something else. Right, well, first thing we're going to have to do is remove this core, which is broken. This is the VCO. And hopefully it's not broken the other way on, so we can reverse it and put it in the other way around. Oh yeah, so what I'm not telling you is what I discovered on the data sheet. There isn't a problem with it being 7 point something volts. So that's going to have upset probably the VCO, and that's why it's probably not working, because the VCO voltage would have altered. We don't have a setting as such, it's a matter of probably monitoring the lock detector. It'll start working when I get this to a position, I'm sure. Oh well, it hasn't. What about transmit? Let's go into transmit and fiddle with it. Ah. Right, that's giving us a receive, but it might be a false lock. We haven't got transmit. I'm not barking up the wrong tree, am I? I mean, that's 3 microvolts, so that's normal. So as you can understand what's happened, this is the only coil that's really been fiddled with at any point as far as I can see. So because this Zener has gone open circuit, the voltage has risen from the normal 5.1 volt. Well, I think it's 5 volts exactly with the original Zener diode. It says 5 volts. Well, that's not what we call a preferred value, and it's 5.1, so it's going to change anyway by changing that. So we've already shown you've got 5.1 volts instead of 7 point something. But if you imagine, if you've got if this whole thing's running at 7 volts instead of 5, then the VCO voltage is going to be wrong. I've got convoy coming over the background music system, but we also monitor our local repeater, which I own. And I'm just thinking, have we got some pirate playing convoy on the repeater? And of course, it's the background music system which happens to be playing convoy. That made me prick my ears up. Yes, so there we go. So if this is supposed to be 5 volts and then suddenly it's 7, this VCO voltage is going to go out. So the radio's going to stop working. But it's when we look at the data sheet, it says wide supply range of 4.5 to 12 volts, so 7 volts wouldn't hurt it. So there you go. We already checked the oscillator when it was under 7 volt conditions, and that was running. But we haven't got transmit, so it might have blown something else. Just see if there's a better method for just, instead of just fiddling. And we could monitor the lock detector. It's not like, this isn't like when you're doing a cybernet set with the Sanyo synthesizer, or whether we're using a Uniden set with the Toshiba synthesizer, where you've got a specific voltage to aim for, which is normal, like 4 volts for a logic high. It's either locked or not locked with this type of chip. It's interesting to show the examples, by the way, in this data sheet from Motorola. This is a typical block diagram of it used as a citizens band on a citizens band radio, and this is the same chip used on an aircraft radio to generate up to, what did they say? Something like, what did they say? Up to 360 channels. Sorry, so 720 channels using 2 crystals. Or as on a marine radio. So, you know, you can use the same. It's a very versatile chip, but you've got to have all these crystal mixers to make it happen, and they have a cost. So the one chip solutions, like we're used to from Sanyo and from Toshiba, are of course a much better idea. So we have got receive. So we are getting somewhere, thank you, diode. So that's gone open circuit. I mean, it can be static sensitive, can't they? It can be as simple as that. So what is there a specific thing in this conversion thing? Which is basically the same on the DNT as well. I think what we'll do, we'll check that we have our oscillator crystal running at 10.24. So that should be our first thing, because that's going to affect So we'll use this as a frequency counter. So what's our 10.24? We want its oscillator output. Let's look at pin 4. 1, 2, 3, 4. .2371. So if we can bring that up a little bit, with the trimmer here, no, try pin 3. Well, what I've done, instead of setting the frequency, I've set it for peak. I can't look at the transmit frequency because it's not transmitting. But what we can do is see if we can adjust the receive to be on channel. I'm talking to myself because the power went off for a fraction of a second. So we've got a secondary signal generator. Let's take the tone off. So it's miles off frequency. Let's take this off and save the battery. So one of these is receiving, obviously one of these transmits. Its receive is this one. So if we can get that down to null. Well, that's strange. It's having no effect. Why is that? That should be the transmit one. That should be the receive one. Right, so here's the next observation. This IC, I think it's TA73, KIA 7310. I've gone and left the circuit in the other room. It's getting warm, and I wonder if there's a fault on that. It's got a short circuit. I've checked the data sheet on it, and it's quite capable of working at 7 volts. But there you go. That's getting warm. I wouldn't expect that to get warm. I'm going to take it out, and the radio, the synthesizer chip should operate if it can operate. But I just wonder, you know, if the synthesizer is toast, because the inputs will have gone higher than intended, and I can't get any. I can't make any adjustment to the crystal, the 10.24. So we'll get rid of this IC and switch it back on. Not sure if I've got these in stock. Got a sneaking impression they use them on LCL communicators. And you never know, we might have a scrap chassis of one of those. See whether we can yank that out. They're only about £1.30, so it's not a huge expense. So without this, of course, it won't transmit. There we go. So yeah. Oh, that's interesting. It's a TA7310, which is the Toshiba version. I wonder if that's been changed in the past. I mean, that's a better than. It should be a Kia, but it's not. It's Toshiba. Right. Anyway, I'm going to power the set back up, and we'll see whether we can. Well, first of all, I'll make sure the signal generator is still where it should be. It is. Right, we'll put the oscilloscope back on. Because this test is independent of any VCO lock. So it should be frequency in now. I'm going to have to change the synthesizer chip. No, I mean, what are they? £16.95. Right, I'll get that unsold. You don't want to watch me do that. Right, so that I've had to take that off now and move on to the next set. So that's going to be the end of part 1 of the JWR M2. Next session we might look at the other JWR M2 instead of going further into that. So I took that IC out. I'm going to have to get this other bank of cameras to come on, and we'll start with the next video. So thanks for watching part 1 of the JWR M2. And basically you can see how easily an open circuit Xenodiode can ruin a radio.